All right, general addition rule. So the old addition rule said if these two sets are disjoint, you can just add them. But if there's overlap, we need to subtract something, and here's why. So all of A would be all of this stuff. Or B, so we add all of B, and we would get this stuff. And if you look carefully, there's this section in the middle that I've highlighted twice. Uh-oh. Well, let's subtract that section off so that we don't accidentally count it twice. And that's what we see this is the section that we subtract off, that we've counted twice. When they're disjoint, there is no overlap, and so this would just be a big fat 0 that we'd have to subtract. So or is the same as union, and is the same as intersection. Okay, an or is an and or. I'm happy to be an A and or B. I'm happy to be an A and B or B. Okay, but let's do some practice with these so you can see how it works. Zach applied to Princeton and Stanford. Princeton, 0.4, Stanford, 0.5, both. Always, always, always start with the central intersection, if at all possible, okay? Something that is not like, because this 0.4 is split between here and here, and I don't know, I don't want to put all 0.4 out here because then there's nothing in the overlap, and I don't want to put 0.4 in here because I don't know how much is supposed to be in the overlap, but if you start in the overlap 0.2, then Princeton, the rest needs to be, now that circle is 0.4, and Stanford needs to be 0.5, so that's got to be 0.3, okay? Same thing here. Princeton and Stanford, they intersect with 0.2. The rest of Stanford needs to add up to 0.5. The rest of Princeton needs to add up to 0.4, okay? And then we know the whole thing has to add up to 1. And so you can figure that out. This has got to be 0.5 and 0.6, which means this must be 0.3, which is neither Princeton nor Stanford. It's 0.3. Okay, so you can see the 4 numbers here are these same 4 numbers here, and the totals really show up on the outside. The totals show up in this circle and this circle, okay? Venn diagram, check, neither, 0.3, neither, 0.3, and, oh, my pen's a little messed up, sorry about that, and Stanford but not Princeton. So Stanford but not Princeton is this 0.3 as well. Stanford, but not Princeton, is 0.3. All right? So let's try a crazier one. Common sources of caffeine are coffee, tea, and cola, which I'm calling soda. Okay? Trying to fill this in, I know that the total coffee has to be 55, but I don't know how much go in these 3 spots. So I'm looking for the intersections, which right here, this is the first place I want to do. 5%. 0.05. And then we can say, okay, 15 drink coffee and tea. So coffee and tea must be 15, and 10% is already used up, or 10% is here because 5% is used up. And coffee and cola, coffee and soda needs to be 25, and we have 5% there, so this must be 20. Cool. 5% drink only tea. That one I can do. That's the only tea out here. And then we can say, oh, this one is only missing 1. So if I know the total of tea is 25 and we have 5, 10, 20, this must be the last 5. Cool. 45% drink soda. So there's 20, 30, 15 more will make 45. 55 drink coffee. We have 20, 30, 5. So we need 20% more to get up to 55. And then we can fill out the outside, which we need for part B, by making sure that the whole sample space adds up to 1 or 100%. What percent drink only soda? 15%. Okay. If we add up all of these, what I like to do is start out with my 55, and then I can go, there's another 25, so we're up to 80, which means there must be 0.2 out there. Okay, so just start with a whole circle. I know this is 55, 60, 65, 70, 80. Okay, but that's the kind of stuff that you're going to get to do with the addition rule. Okay, you got to be careful of those overlaps, and filling in the overlaps first is the easiest way. Good luck. See you soon.